Morning, guys. Hope you guys have written the examination properly, right? And and I believe you guys have are comfortable with the section which I'm going to take. That is, we have completely finished the chapter uh, work energy power on the basis of your textbook. NCRT thing is completed. But as I said during the live classes and during the recorded classes, as per se, that I will be finishing the next 2 hours. I will be taking extra for needs section, right? Because I couldn't mix up the, actually I always take like this, that is some of the portion will be NCRT and along with it I will finish the need, then again NCRT, or I will mix up, right? That's the way I take, right? So again I'm mentioning that this is not the way I'm supposed to take, because the collisions while I was taking, right, I was supposed to take it purely a mix-up of both NCRT as well as your need section. But what happened is declaration of examination, so I first finished the NCRT as such, right? So today we'll be purely taking need sections, but you guys can even use the theory section which I'm taking for your preparation on the basis of your knowledge, right? Because 11th section, guys, it is very important. I talked with some of you guys and you guys actually thought that 11th is easy, you can just sit idle and you guys can finish off the 11th and you just have to learn properly during the 11th class. That notion is wrong, right? Because in the case of any entrance examination, 11th carries a lot of weightage. So now without understanding 11th, you cannot even appear in 12th. There are two chapters, that is wave optics and ray optics. Without understanding waves and oscillations, which is in the 11th class portion, you cannot touch it. Clear? So you guys have to be thorough in the 11th portion also. Okay, now the second thing which I have to ask you guys is, while you listen to the classes, that is video classes, make sure whenever I mention that this is a neat topic, please write on your notebook there in the above section neat like this, and then write the topic as it is. Because many of you guys were calling me continuously and asking me whether this is a NEET or not, whether this is a CBSE topic or not, right? Any extra equations is something which is present in the NEET, right? So I would have just go through your textbook, guys, while I was in one video, maximum 2 or 3 topics would be covered, right? For the corresponding topic, look into your textbook, then you can confirm how much extra I'm taking, right? Numericals, actually, see, it's not extra, but in school sections, let's face it, in CBSE they don't go deep, because 11th marks no one is going to give importance to. That's why the 11th class, most of the time, they, in CBSE point of view, the teachers don't go deep, right? But that is not what is going to happen now, right? You guys are in an integrated batch, so you have to understand how much difficulty you would be facing. But in order to make you guys help to face that difficulty, we teachers will be along with you guys. Okay, so moving on, we had a lot of idle talks. So first, just like the collisions, you have an idea, right? There are majorly 2 types of collisions you can talk about: elastic and inelastic collision. I'm not talking about a perfectly inelastic collision, just commonly we can say it as elastic collision and inelastic collision, because the major thing which we have to deal today, or in the 2 hours which I will be taking regarding the collision, is purely on elastic collisions and little bit only on inelastic collision, right? So let's start with elastic collision. Right, now elastic collision is also called head-on collision, right? And just like the previous thing in the NCRT section which we took, I told you there can be 2 type of collision. One is one dimensional and the other is 2-dimensional collision, right? And out of this, actually the elastic collision, head-on collision comes in what? 1-dimension collision, right? So I'm not going to detail in that section because something you have learned, right? So m1 is a mass, let's say it is moving with a velocity u1, right? In the same axis, another mass m2 which is moving with velocity u2, let's say like that, right? actually what happens is M1 will stick with M2. Let's say, right, let's say M1 will be deformed like this, and M2 might be deformed like this, right? So this is M1 and this is M2. That is what happens. Two cars, right, they collide. Don't you feel they will be deformed, right? So let's say like this, let's say M1 and M2 are very elastic in nature, right? Or they, when they collide, right, both will be deformed, right, for a fraction of seconds, right? After that, again, let's say M1 has regained its shape and M2 is also regained its shape, right? So that, but their velocity has changed to v1 and v2 respectively. Now I have said this is a perfectly elastic collision. See, it is when M1 and M2 after collision they are actually deformed, but later, just fraction of a second, they again regain their shape. This is an example for perfectly elastic collision. Right? This is actually the perfectly elastic collision. What happened in your textbook is you or usually take M2 as rest, right? So that cannot be sure, right? M2 can be also moving in with the velocity. Then also there will be condition where they are undergoing elastic collision. This is what we are doing here. Suppose M1 is also moving with velocity and M2 is also moving with velocity U2. After collision, they are respectively getting V1 and V2 velocities. Now, major criteria for a ideal collision is their conservation of momentum, right? Conservation of momentum of what? Momentum of system, not individual case. Individual mass M1 is having a velocity change, right? So its individual momentum changes, but the sum of momentum before collision and sum of momentum after collision is same. That's why we say conservation of momentum of the system. Clear? Right? Now similarly we have talked about how kinetic energy doesn't change. That is, kinetic energy will be equal to kinetic energy final, or I can say conservation of kinetic energy. See, that's what I wanted to make sure, guys. Actually kinetic energy is not conserved, right? But in your textbook, as per to make it simple for you guys, it is said that the kinetic energy is conserved in the case of elastic collision. But properly, if you ask any person who has deeply studied physics, if you ask you tell them that the kinetic energy is conserved in elastic collision, he will say it is wrong. Because see, a mass M1 collided with M2, for fraction of second the shape changed, right, like this, right, the shape changed like this. So that time M1 might lose some kinetic energy, and M2 might gain some kinetic energy, or they might lose some kinetic energy to the environment. They can happen. But it is found that after that deformation and they get their initial shape, then the kinetic energy, this final kinetic energy of M1 and M2 is equal to initial kinetic energy of M1 and M2. That is what actually statement, right? Because there is an intermediate step where the kinetic energy can change. But obviously, final kinetic energy is equal to initial kinetic energy. That is a small change, but good to know things, right? Now let us say, right, the same scenario. M1 is having velocity U1, M2 is having U2 velocity. After collision, let's say M1 is having V1 velocity and M2 is having V2 velocity. Now what happens? Suppose the M1's velocity is greater than M2's velocity. That is, U1 is greater than U2, right? Then only the mass M1 can collide. Common sense? Right, let's move on to the first figure itself. Say, suppose this M1 is having low velocity, let's say 10 meter per second, and M2 is having 30 meter per second. M1 can never reach M2, right, because it's of low velocity. So it is a common sense that if M1 has to collide M2, then U1, that is its velocity, should be greater than the velocity of the second one. Common sense, then only a collision can happen, right? See, this can arrange, it's okay. That is M1, suppose it's having velocity U1, let's say 10 meter per second. M2 can move with a plus 20 meter per second, but in this direction. So that means it can be what? A negative direction. Then also see, U1 is greater than minus 20. I took this as minus because this direction I am taking negative and this is positive. So always keep in mind, if you have to have a collision, right, then U1 should be greater than v2, right? Now these are all very important small things which you have to know, right? Similarly, I hope you remember, you can write just like due to the conservation of momentum, you can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, right? Let us arrange this like this. Bring the m1 terms nearby. u1 minus uv1 is equal to m2 v2 minus u2, right? Let's mark this as first equation, right? Now similarly, you can write kinetic energy initial is equal to kinetic energy final, right? This is first section, this is second section. Half m1 u1 squared plus half m2 u2 squared is equal to half m1 v1 squared plus half m2 v2 squared, right? So from here, let us remove 1 by 2, right? And bring m1 terms here. So it becomes m1 u1 square, and there is an m1 v1 square here, right? So it becomes here m1 into u1 square minus v1 square is equal to m2, right? There is a v2 square over here. v2 squared minus u2 squared, right? So you have two equations now, right? This one and this one. Let us divide the second equation by the first. 2 by 1, right? Second equation by 1. So this m1 term goes off, and this is u1 squared minus v1 squared is u1 minus v1 into u1 plus v1, right? And there is this denominator, that is u1 minus v1. I can cut this off, right? So straight away I'm going to write as dividing the second equation by first equation. I can write u1 plus v1 is equal to here v2 square minus v2 square, right? So v2 minus v1, or I can write v2 minus u2, v2 plus u2, right? You got an expression like this, right? Now I'm going to rearrange this equation. This is very important, right? Let's bring the initial velocities in one side. u1 minus u2 is equal to v2 minus v1. Very important, because you are going to get a sense of something. That means, what is u1 minus u2? Initial velocity of two masses, right? m1 and m2. Velocity difference between these two masses. What does it say? That means u1 minus u2 is the relative velocity between mass m1 and m2 before collision, right? u1 minus u2 is a relative velocity. I can write it as u12, right? Relative velocity of mass m1 and m2 before collision. So what is v2 minus v1? That is the relative velocity between mass m1 and m2 after collision, right? You can write v2, okay, v2 1. So I can just say, as per this equation, that very important criteria for ideal elastic collision, that is relative velocity, right, before collision should be equal to relative velocity after collision. This is something which you don't see in your textbook, but it is a very important point, right? That is, during a perfectly elastic collision, the relative velocities of the two bodies should be equal to the relative velocity between the body after collision. Their relative velocities are constant, right? That is, during an elastic collision, the relative velocity between the bodies doesn't change, because using that criteria we can do a lot of problems. That's why. That is, let's say this is a 2 kilogram mass moving with a 5 meter per second velocity, let's say like this, and another, let's 3 kilogram, right? Let's say it is moving with 2 meter per second. Obviously this is greater than 2 meter per second, so it can catch up, right? They will undergo collision. Let's say 5 kilogram, right? This one, not 5 kilogram, what velocity it is? 2 kilogram, sorry. Let's say this 2 kilogram moves with the velocity v1, and 3 kilogram goes with the velocity v2. See, I am not talking about inelastic collision here, guys, because that is not of that important. That much questions are not asked from that phase. Okay, so and you are told to find the value of v1 and v2. What is the velocity of 2 kilogram and 3 kilogram, right? See, you can do it by the what? m1 v1, sorry, m1 u1 plus m2 u2. It's not wrong, but we are going to use a criteria. And also, sorry, suppose a question has been given that it is a perfectly elastic collision, so find the value of v1 and v2. That's a question. Okay, so always use the criteria or the parameters of a elastic collision which we have taught now. So first is what? There is a conservation of momentum, so you can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, as I said before. So what is m1 u1? 2 into 5, 10 plus 3 into 2, 6 is equal to m1 2 into v1 plus 3 into v2. That is the only equation you can write, right? Clear? So what is 10 plus 6? 16. Let us make this as one equation. Keep here. Right? Now, remember, during elastic collision, perfectly elastic collision, the relative velocity is before collision should be equal to relative velocity after collision. What is u1 minus u2? That is 5 minus 2, that is 3. Is equal to what is v2 minus v1? You don't know. You write it as v2 minus v1. You got a second equation. Right? This is how we can solve the problems, guys. Right? Now, what can I do to solve this one? Very easy. Let's multiply this. Okay. Let's multiply this equation with 2, right? So what happens here is 6 is equal to 2v2 minus 2v1, right? This is your third equation. Let's add this 1 and 3, right? So it becomes 22 now. 22 is equal to 5v2, or I can write v2 is equal to 22 by 5, or it is what? 4.4 meter per second. Aha. Meter per second. Similarly, we can find v1 also. See here, v1 is equal to v2 minus 3, right? So v1 is equal to v2 minus 3 means 4.4 minus 3, right? So it will be equal to 0.41. 1.4 meter per second. You can find the answer, right? Not a big deal. Let me mark this one. Okay, clear? Right. So this is how you solve the problem without much problems. Let's say 1 kilogram. Let's say it is moving with the velocity u. Let's say there is a mass m. Let's say it is at rest. So its velocity is 0. Okay, I will write it here. u2 is equal to 0. u1 is u. Okay, let's say after collision what happened is this 1 kilogram mass moved back with the velocity u by 3, and the mass m has a velocity v, right? Now your question is this one, find this mass. How much is the mass value, right? So, and you are told this is a perfectly elastic collision. So how would you find m? You will obviously go for what? Perfectly elastic collision means better use these two criteria. What? I will make this half. There is a relative velocity between these two guys. U1. This again, guys, this is a neat point of view how to handle the questions, right? That much steps we can draw. Or you guys, if you use the second, there is neither criteria for perfectly elastic collision, that is initial kinetic energy is equal to final kinetic energy. That much time consumption because you have to square the velocities, etc., etc. So you can reduce the step, right? So what is the first point better to use? That is the relative velocity before the collision, which is u1 minus u2, that is u minus 0, right, is equal to v2 minus v1, v minus u by 3, right? Or u is equal to v minus u by 3, right? Now guys, if you can write v minus u by 3, I'm going to cut this one. See, it is v2 minus v1. But here, this direction if I am taking positive, this direction if I am taking positive, then this direction is negative. So it is minus u by 3. So v2 minus v1 becomes this, right? So here it is v plus u by 3, so that the velocity of the mass m becomes u minus u by 3 is 2u by 3, right? The direction is very important because velocity is a vector quantity. Now, similarly, the second rule which you can use for doing elastic collision problems is, it is a conservation of momentum. So m1 u1, that is 1 into u, this is rest, right? So m2 u2 becomes 0, right, is equal to m1 v1, that is 1 into u by 3, or I must say minus u by 3, plus m into v2, right? In place of v2 I have to write v, that is u is equal to minus u by 3 plus mv, or this u by 3 goes here, that means 4u by 3 is equal to mv. Now we have find the velocity of the second mass as 2u by 3. So 4u by 3 is equal to m into 2u by 3. So u by 3 cancel. So you will get mass m as how much? 2 kilogram. See, this is how you did the question. Clear? Not big deal, right? This is very simple questions regarding your what can I say, regarding collisions, perfectly elastic collision. Okay, now the next section which I'm going to take, you can see that in your essay. Okay, so again, purely NEET or any entrance, JEE, whatsoever entrance topic, not there in your textbook, right? That is E, that is coefficient of restitution. Coefficient of restitution, that is it is actually a criteria to say whether a collision is coelastic, inelastic, or partially elastic whatsoever, or I can say a criteria by which you can say what type of collision it is, right? That is coefficient of restitution, a parameter which helps you to say what type the collision is happening, what type of collision is happening, is known as coefficient of restitution. And its expression, actual expression, is velocity of separation by velocity of approach. You just write down, guys, because you need not go for this section in detail, because you just require the basic equations which can be generated, and by looking at E, how can you say whether it is a what type of collision it is. Okay, no need to go in deep, just mug up E is equal to, that is coefficient of restitution is equal to velocity of separation by velocity of approach. That means, right, so this, if you understood the equation, there is another format for writing for velocity of separation by velocity of approach. See guys, don't worry, if possible I will try to dig in deep, but I don't think you guys require that much deep knowledge in the case of coefficient of restitution. We'll do those sections where the practical application of E has been happened in regarding questions. We'll do it. Okay, so what were I talking? So there is another way of approaching coefficient of restitution, which is a relative velocity after collision, that is obviously between bodies, that is relative velocity between the bodies after collision divided by relative velocity before collision, right? Or I can write the equation, relative velocity after collision is v2 minus v1, and what is the relative velocity between the body before collision? It is u1 minus u2. So there is an equation for E now, that is coefficient of restitution is having the equation of v2 minus v1 by u1 minus u2, where v2 minus v1 is the velocity, relative velocity of or I can say velocity of separation, and u1 minus u2 is actually velocity of approach, right? And there is no unit for E, guys, both of them are velocity quantities. Now if you know that in the case of elastic collision, right, relative velocity between the bodies before collision and after collision are equal, that's why you can say if E's value is equal to 1, you can perfectly say that it is a elastic collision, right? So somewhere you see in the problem that given as E is equal to 1, you suddenly say yes, that is a elastic collision. Now if E is equal to 0, then that means it is an inelastic collision, right? Clear? So sometimes the E might lie between 0 and 1, right? Clear? That type is actually a partially elastic collision. So I told you by looking at the value of E, we can say whether a type of collision it is, right? So when E is equal to 1, it is an elastic collision. If E is equal to 0, it is an inelastic collision. And if E's value is between 0 and 1, it is a partially elastic collision. Clear? Right? Now we are going to find the equation for final velocities of two bodies which has undergone a elastic collision, right? So elastic collision, right? Final velocities of both the bodies, that is final velocities v1 and v2. We are going to find the expression for them. Okay, see, we have found the values of v1 and v2 as per your textbook, but remember, while we were deriving in the textbook format, I told you that the mass m2 was kept at rest, right? But guys, in NEET, never they are going to say that m2 is at rest. Yes, obviously they might ask, but it is better if you get an equation where both the velocities are mentioned, right? Then you can say, if the second body is at rest, I can substitute u2's value as 0, like that. It's better, right? So as I talked to you guys regarding the same in your live classes, right, now I'm going to find, and I asked you guys to mark those two equations in your SM, right? Now we are going to derive that equation. No need to by heart this derivation, but I want to make you understand from where that equation came up, right? Now, so there is two masses, m1, let's say it is having velocity u1 in this direction. m2 is also having a velocity u2, right? It is not at rest, right? So they are undergoing collision, so that now m1 is moving with the velocity v1 and m2 is also moving with the velocity v2. Now we are going to find the expression for v1 and v2. Okay. Now, so as we said, the heading is elastic collision. So what do you learned about elastic collision? You can use the equation of conservation of momentum and the relative velocities are equal. So u1 minus u2 is equal to v2 minus v1. Right. Now I'm going to rearrange this equation so that I can write just v2 is equal to u1 minus u2 plus v1. Keep this expression to derive the final velocity equations, right? Now the second is u by conservation of momentum, right guys? See, don't expect me to write the entire sentence on the board, right? So I will be verbally telling you, so it is better if you can write as I am telling you now. Okay, so by conservation of momentum I can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Not big deal, you know the equation, right? Now what I'm going to do is I'm going to substitute this v2 value over here so that this becomes m1. Okay, right, m1 u1 plus m2 u2 is equal to m1 v1 plus m2. Now in place of v2, what I'm going to do, I'm going to substitute this value as u1 minus u2 plus v1, right? Let's bring the bracket out. No, remove the bracket. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 u1. Let's put a tail for u, right? So m2 u1 minus m2 u2 plus m2 v1, right? Now just listen how what I am doing. I'm going to, no, this is u1, no? Right? m1 u1 minus, I'm going to bring the u1 term here. So m2 u1, right, plus m2 u2, then there is an m2 u2 here also. Let's bring here, so it becomes m2 u2 is equal to m1 v1 plus m2 v1, right? So both the terms are having v1 as common. Let's bring v1 outside, so it becomes okay, sorry, so what happened? Okay, equal to what? v1 common m1 plus m2. Okay, now m2 u2 plus m2 u2, this one m2 u2, this m2 u2, I can write it as plus 2m2 u2, right? I'm going to bring this m1 m2 below to it, as well as to this first term. U1 is common, so U1 is M1 minus M2 common. This is also having a denominator. This one as M1 plus M2. This is actually equal to V1. This is the expression for the final velocity of the first mass, right? It is very easy to by heart this equation. I don't know why kids find it difficult. See, you want the velocity first. So first write its initial velocity, right, into mass difference, that is M1 minus M2, and denominator is always M1 plus M2 itself. Don't worry, both the cases. Then you write plus 2, right? You want first one's right mass, right? In place of that, write M2 U2 divided by M1 plus M2. It's very easy, right? I will tell you the same method you can use for what? Your velocity, final velocity of second mass. See, V2 I require. So V2 I require means here in place of M2, that is V2 I require, so I will write M1 here. M1 U1 divided by M1 plus M2. Right? Now the first term becomes what? In play, when you wanted first mass, you wrote its initial velocity. Similarly, U2 M1 minus M2 divided by M1 plus M2 over. This is the second mass final velocity. Second part, how would you write? Denominator is same. Oh, what? M1 plus M2. Don't worry, right? You require V2. So for you, mass 2 is greater important. So you will write M2 minus M1 and you require V2. So again, your initial velocity of the second mass is important, right? So this is the expression for V1 and V2. You guys can by heart in any ways, but it's better to have tricks for remembering the equation, right? Right, so you got two equation. See, let's see if you can get the same equation you have learned during your, when I was teaching the derivation of V1 and V2. We assume that the second mass is at rest, right? So this term becomes 0, right? due to the terms goes off. That's why you wrote in V1's equation as U1 into M1 minus M2 divided by M1 plus M2. This is what you derived in your or for our NCERT textbook syllabus, right? Similarly, in the case of V2, this terms, right, M2 U2, right, this term goes off, this entire term goes off, and there is only this part, that is V2 will be equal to 2M1 U1 by M1 plus M2. See, so you get the equation which you derived during the class hours also, right? So actual equation is this one, in which you are substituting that initial velocity of the second mass. If it had been 0, then you can get the equation like this. Not a big deal. Okay, so better by heart this one, this equation. Okay, right. Now here also, just like the some of the cases, you also have to deal some of the cases here. Case 1. Now suppose M1 is equal to M2 is equal to M. That is both the bodies which are undergoing elastic collision, let's say they are having equal masses. So V1's equation, let's bring that one. Can I copy paste? I don't think so, right? So here this expression, right, let's talk about V1. What happens? All the masses are equal, that is both the masses. So M1 and M2 are equal means this term goes off, right? So this term can be written as 2M U2 divided by M plus M. So denominator as well as numerator will have 2M. So it will get U2 as the answer, right? V1 will be equal to 2M U2 divided by 2M, M1 plus M2, right? So this M, this 2 cancel. So you will get V1 is equal to what? V1, that is the final velocity of the first mass, is equal to initial velocity of the, sorry, not the U2, no, it's U2. Initial velocity of second mass. See, initially M1, this is M2. Let's make this M. Both are mass M, right? And this one was moving with U1 velocity. This one was velocity U2, and they undergo collision, right? After collision, this is M, which is having V1 velocity. This is having v2 velocity. It is said that v1, if you just put the values, right, as said, as both of the masses m1 and m2 is substituted with m, the first term goes off, m1 minus m2 term goes off, and there is only 2m2 u2 divided by m1 plus m2. So it is 2m u2 divided by m plus m, that is 2m. So numerators 2m, denominators 2m cuts off, so you will get v1 is equal to u2. That means, I hope you understood, that is, if two equal masses are colliding, right, so the second mass velocity is now carried by which one? By the first mass. After collision, so listen properly, after collision, the first mass is having the velocity of the initial velocity of the second mass. Similarly, if you put the values, you will also find final velocity of the second mass is equal to initial velocity of the first mass. Second mass will have the velocity of the first mass, right? So I can say there has been an exchange of velocity between the two masses, right? Clear? This is a very important criteria to solve some problems, right? So in elastic collisions, two equal masses, if they are colliding, they exchange velocities. By using this, very beautiful questions are there. Okay, let's first understand the basic of it. That is, if you have 2 kilogram mass, let's say it is moving with 10 meter per second, right? And there is another 2 kilogram mass, let's say it is moving this direction with 1 meter per second. If they undergo elastic collision, then the first 2 kilogram will move with 1 meter per second in this direction, whereas the second 2 kilogram will move with the 10 meter per second in this direction. They will move away from each other, right? Similarly, that is, if you are having a 20 kilogram moving with 5 meter per second in this direction, let's say if 20 kilogram, another mass, it had been at rest, right? So what happens is this 20 kilogram will now at come rest, that is the first 20 kilogram will come at rest, whereas the second 20 kilogram will start to move with 5 meter per second in this direction. Aha. Right, this is 5 meter per second. Clear? Right, I hope the concept is clear. Right, now using this question, that is a very good JE question. Right, suppose there are two masses, right, and both the masses are identical. Let's say there is a point A here, let's say there is a mass here and there is a mass here, right? Let's say this mass is moving with the velocity v in this direction, and this velocity mass is tangentially, both of them are tangential per speed or velocity. One is with v and the other is 2v, and they are following a circular path. That is, see, this is moving in this direction, let's say, and this is moving in this direction, right? Clear? So your question is, after how many collisions will they again meet at A? They started from A, they collided at A like this, right? They, after collision, actually they were moving like this, right? So you are asked after how many collisions they can come up at A again, right? So again, your some of the common sense section is very important while doing this problem. Why? See, after collision from at A, this ball will be moving here and this mass will be moving here, right? At somewhere, no, I'm just assuming, let's say at this point, right? They again undergo collision, right? Same masses now, right? Same masses. So again, one will be moving this direction. Again, after collision, the other one will be moving in this direction. But what happens? There happens exchange of velocities because they are equal masses. And it is said in the question that they are undergoing elastic collision, right? So similarly, after here one collision, again they might move in this direction. The one will be moving this direction, the other moves in the other direction, and they might be meeting here, right? Again they undergo collision, and like to and fro motion will be there, right? So you don't know from where to where they are going to undergo collision, or where and all you can say. Just pictorial representation cannot help, right? So you are supposed to find that after how many collisions as such they can come again and meet at point A. Clear? Right, and it is said that always the speed is constant. That is, after exchanging one speed, again the velocity is constant. That is assuming that the masses are moving with constant velocity or speed between two successive collisions. That is also mentioned in the question. Okay, so how would you do it? Sorry. So when the balls are colliding at some point, they will be moving away, right? And then again they move and then they again collide. Like that's what happens, right? So let's say at A, right? Let's mark this velocity or points or masses. Let's say this is x and this is y. That is, x is moving with velocity 2v and y mass is moving with velocity v, right? So that means x is having double the velocity of y. So x will be moving double the distance, right? So x will be moving double distance when compared to y, right? Because its velocity is double. Proportionality. Okay. Okay, in the same time interval. Okay, so in order to solve this problem, what we are going to do is, let us divide this. Okay, I hope you understood what A point is. I'm not going to write this A again. Let us divide this circular path into three parts like this. Okay, so let's start from this. See guys, very important, because you guys have to listen what I'm taking. Okay, so from point A, this is your point A, right? So x and y moved in the opposite direction, so obviously x is going to cover a larger distance now. So let's say x has moved in this direction and it's gone. Okay, I'll take this rubber. Moved in here direction and it completes double distance. This section and this section will be covered by x, but y would have covered a small distance. So let's say, see, this is the equal part division has been done now. So when y is covering one part, x would have covered double the part of it, right? So now at this point, both x and y again undergo collision, right? So x is meeting here and y is meeting here, right? Now at this point, right, now x will have the velocity of y, that is v, right? X will be moving, right? I hope you understood which is the direction of velocity of y. It is in this direction. Now it's moving there. So now here at this point, now the x will be having the velocity. This is x. Now x will be moving with velocity v and y will be moving with the velocity 2v. Right, because both are exchanging velocity and the same direction will be happening, right? Clear? So this is a velocity of y and this is a velocity of x. Exchange of velocities happened, right? So this much is clear, right? Okay, now after this collision here, so one collision is completed. Now x is having how much velocity? V velocity, and y is having 2v velocity. That means now y will cover double the distance as that of x, right? So now currently after collision, the y is moving, right? In this direction, it will try to move in how much velocity? Double velocity. That means now y would move like this, and let's say it has reached this point here, right? Similarly, x would have come in this direction in the velocity v and it would have reached here, right? Clear? It now has reached here. So now the second collision has happened here, right? So in the second collision means, again, see, this is the direction of what our let's say y, y was here, right? So its velocity now x will have, right? So x now will be varying with the velocity 2v in this direction, because that is the direction of y initial, right? And y will be varying with the velocity of x in this direction with velocity v, right? Clear? Right. So how many collisions is now completed? 2 collision, right? And now x will move with the velocity 2v and y is moving with velocity v. So who is having double distance coverage? X. So now after this collision, x will gradually move with 2v velocity and reaches this A point. Similarly, y will be moving this direction with velocity v and reaches this point, because the distance half the part of A. Right now it has again reached point A. So that is during the third collision it is reaching. So how many collision has happened? 2 collisions have happened. Third collision you cannot add, right? So how many collision it takes to meet at A? 2. After 2 collisions it is meeting, right? Between, that is pure 2 collisions, or you can say on, if you are asked on which collision it is happening, you can say on third collision they will meet, right? Clear? I hope you understood. Right. Okay. Now let's move on to another problem. Question is, suppose there is a mass A like this. Let's say it is moving with velocity v, and there is a B mass which is connected with C with a spring with a constant K. And let's assume they are on a smooth, right, plane, and mass A of mass B as well as mass C are equal. Let's say they are both, the three masses are having the mass M, and A and B are going to have elastic collision, right? That's a question, guys. I'm not writing the entire question. Please write it down by yourself. Okay, there are three systems, like there are three blocks. Each of them are having equal masses, let's say M. Out of this, A is moving with velocity v and it is undergoing elastic collision with B. Now the question asked is, what is the maximum compression in spring? Second, find the kinetic energy of the system when the spring is under maximum compression. Repeat the question. I am again repeating. What is the maximum compression of the spring, and what is the kinetic energy of the system when the spring is under maximum compression? This much clear? Right. So A and B, if they are undergoing an elastic collision, B is initially at rest. Okay, that's also mentioned. If I am not at all you guys, I'm sorry. Obviously, nothing has been marked in the question. So obviously that means B is at rest. Similarly, C is also at rest. So when A is undergoing an elastic collision with B, so B will now move with velocity v, as well as A will be coming at rest, right? So A will be at rest. Now B will be moving with velocity v, right? Now you can just forget A, just for now. Okay. Now when B moves with velocity v, will it not compress the spring? Yes. Right, then the spring will also act a force against the application of force or velocity which is done by B. That is known as spring force, which actually it's equal on B and C. Right, clear? Let's say, I hope you understood the scenario. So when the B is moving with velocity v in this direction, so the spring will be compressing, right? And because of which, when the spring here compresses in this direction, that means the C will be pushed outwards, right? I hope you can understand the scenario. B pushes here, C will be pushed out, right? Clear? So that means I can say B's velocity gradually starts to decrease, whereas C's velocity starts to increase gradually. Till when does this process happens? Till velocity B will be equal to velocity C, right? Because once the velocity of B and velocity of C becomes equal, now there is no need for the compression. That is the maximum compression that can happen in the case of spring. I hope you understood. See, B's velocity is V, right? V, velocity, vector A, velocity. It is moving in this direction, only B. Just a second. Okay, just a second. Now B is only having velocity v and C is at rest. Okay, so B pushed the spring in this direction. So what would the spring feel? It will undergo compression. Along with it, it will push the C in outward direction, right? So as the velocity of B will obviously starts to reduce, similarly C's velocity goes on increasing, right? That means your spring is getting compressed also. Now at some point, the velocity of B and velocity of C becomes equal. That is, how much velocity by which here it is moving, the same velocity by which only the C will be moving. Let's say that is, suppose B is moving with 2 meters per second in this direction. C was also moving in 2 meters per second in this direction, means now the spring will not be further compressed. I have taught it this in a detail in your spring section. If the compression here and the compression here in both of them, or see, if this is a compression in the place of B, here what happens is an elongation. Due to B is compression, due to C is elongation. That's why it negates. Okay, if you want, I can even tell this example with what, let's say numerical value, that is better. Let's say B is moving with a velocity 3 meters per second. Initially C was at 0 rest. Now what happens is, let's say B's velocity decreases to, let's say 2 meters per second. Let's say C has a rise in velocity by 1 meter per second. Now let's say what happens. So obviously now still now the no, this push is greater than this pull, right? This push is greater than this pull, right? So obviously the spring is still compressed. Now let's say velocity of B is 1.5 meter per second. Here also the speed of pulling is also 1.5 meter per second. So here there is a pull, here there is a push, right? The spring is not going to compress further, right? So I can say when the relative velocity between B and C becomes 0, right? Relative velocity between B and 0, that is both of them have same velocity. At that point I will say there is maximum compression occurred. No more compression can occur. That is the maximum compression that is possible, right? Now let's say during that maximum compression, let's say B's velocity is x, then C's velocity will be also x, right? Now this is a system, right? So obviously the momentum is conserved, right? So I can write mv, that is the velocity of B before collision, right? You are taking only the system, guys, no need to take A, right? That has done its job and gone off, right? So sorry, right? So m into V, that is the B's velocity, plus m into C's velocity is 0, is equal to m into velocity of B is now x. Similarly, m into C's velocity is also x. Now you can find the value of x is equal to V by 2, right? That is, see, both B and C will have equal velocity, or I can say when a block A collided with B with a velocity V and it undergo elastic collision, right? So after that, if B else, obviously B will be having velocity what? V now after collision, and this A comes to rest. Now this B will start to compress the spring which is between it and C, right? Till when? Until both the velocities of B and C is equal to V by 2. Till then only the compression happens. After this equality of velocity happens, no more compression, right? Clear? So the velocity of B and C now has reached its maximum value as V by 2. Now, so before going to the first part of the question, let's do the second part. What was the second part? Kinetic energy of the system. That is BZ now. What is kinetic energy of the system? Now this one is addressed. No need to find this one. Half into m, that is the mass of B. What is the velocity of B? That is V by 2 whole square, plus half m V by 2, that is the velocity of C, do V square, right? So it is what? mv squared by 4. Right, there is a second part which is very easy. Now we'll find what is the maximum compression of the spring. So here it is better if you understand. In this case of spring, always the mechanical energy is conserved, right? The mechanical energy initial is equal to mechanical energy final. So what is mechanical energy? The sum of potential energy and kinetic energy. So initially when the system is concerned or considered, only A is having the total mechanical energy, which is actually kinetic energy. It is half mv squared. B and C at rest, so need write the third thing. Now A comes at rest now, right? But B and C are moving with half velocity, so mv squared by 4 is the what? Sorry, right? Clear? Plus potential energy of the spring. Right? I hope you understood. You guys are asking how this mv squared by 4 is being, that is what you have found in the previous section, that is the kinetic energy of the system. Kinetic energy of the system, final kinetic energy of the system, that is mv squared by 4. Plus the spring is also doing some work now, that is there is a potential energy there, that is half kx squared, right? So from here you can find x value as is equal to root m by 2k, and there is a velocity v. This is the value of maximum compression that can happen. Clear? Here the x is compression. Okay, don't mix up with the velocity which you have assumed x in the previous case. Don't mix it up. Okay, right. Now there are some things which I have to clarify, not clarify, but some more things. That is, we have just dealt with one case, right? Similarly, there are multiple cases. Let's talk about case 2 during a elastic collision, right? That is, we had mass m1 with velocity u1, m2 with velocity u2. After collision, m1 got v1 velocity and m2 got v2 velocity. Now what happens if this m2 is very, very, very large when compared to m1? Let's say this is you're running. Okay, that's a better way of thinking, right? And let's say m2 is at rest, that is having velocity. No, don't write m2 is equal to 0. M2's velocity, that is what I'm writing, right? That is u2 is equal to 0, like that. Okay, that is m2's velocity is 0, means let's say the second mass at rest, right? This is just like the scenario, you are running, right, and there is a huge lorry before you and you go striking it, right? What happens? Would the lorry move? No. Now that's what we are going to find. What will happen to you and what will happen to the lorry, right? That is, if mass m2 is very, very large when compared to m1, means for m2 you will feel that m1 is equivalent to 0, right? So in the previous equation of v1, if you substitute m1's value as 0, you will find v1 is equal to 2u2 minus u1, right? When you just put the value m1 is equal to 0, you will get v1 is equal to 2u2 minus u1. But you just said that u2, that is second mass, is initially at rest, that is the lorry is at rest now, so you can just rub it off, right? So v1 is equal to minus u1. What does it mean? Similarly, let's say keep here u2, right, is equal to 0. Similarly, what will be v2 be? Similarly, substitute to the value of m1 is equal to 0. You will find the final velocity of the second body is equal to u2. But you just found that u2 is equal to 0, right? You suffix that, right? So u2 is equal to 0. So v2 is equal to 0. Okay, so just write the sentences here. There is a final velocity of the first mass is minus of its own initial velocity, and final velocity of second mass is 0, which is actually the initial velocity of itself. That is, scenario, understand the scenario. You were moving with the velocity u1, you strike the lorry which was at rest, right? Clear? Then after hitting, you will be rebounding like this. Dishum, dishum. That is minus u1, right? That's what happens now. Whereas the lorry will not move at all. Clear? That is a scenario. That is, if a object which is of smaller mass strikes a mass which is very huge, the striking object will be rebound. It strikes like this, it rebounds it. That's why this is actually a rebounding condition, but the larger mass is not going to alter its position. This much clear now, right? Talk about case 3. Ouch. Case 3. Okay. Suppose that is m1 mass is very, very large when compared to r2. That is, and okay, let's say m2 is at rest. That is the same scenario like this. You are having a huge lorry coming and you are sleepwalking, let's say. Right? So it's just like, or you are just standing over here. The lorry is coming at full velocity. Now what happens? Right? So how will you find the value for it? So that means in the eye of m2, right? Or I can say in the eye of m1, that is this guy. For lorry, you don't exist at all, right? So your mass, I can say, is equal to 0. So I can equate m2 as what? Equal to 0. Similarly, its velocity, that is your velocity, you are just standing now, so velocity is 0, right? This much clear? Now when you substitute m2 and u2 values in your respective v1 and v2's equation, you will get v1's value as u1 and v2's value as 2u1. Just substitute by yourself, guys, not big deal, right? You will get this exact value. Now what does it mean? Lorry comes with the high velocity of u1, it strikes you, right? It doesn't care if you're standing, you are moving, whatsoever. The lorry will move its own speed throughout. It is not going to be affected with you. Or then we ask, oh, then they suddenly stop. That is because the driver stops no, the lorry. It's not due to your collision, the lorry stops. It doesn't voluntarily stop. That someone stops it, he just saw an accident, he stops, right? So when the lorry is moving with a velocity, let's say u1 velocity, it collides with you who has been at rest, then the lorry doesn't change its velocity, it moves on its own velocity, right? Now what happens to you? You will be thrown off, right? You will be thrown with the double velocity of the lorry. That's why what happens in during an accident, right? You will be thrown off like anything, like a potato sack, and you will be thrown out with the double velocity as that of the lorry. That is how the accidents happen. Clear? See, I'm telling the examples in the, by thinking accidents, because it is something which you can understand or relate, or at least you have seen in movies. Hope you never see an accident in your real life. Touch wood. Okay, so I'm just making you guys understand. To understand the collisions, it's better if you can understand the scenario rather than mugging up the equations. Right now, this will be registered in your mind. You have to register in the mind. So when you are colliding with a lorry is not going to have any feeling. You will be rebound, right? But when a lorry strikes you, then the lorry will never change its velocity. It moves as it is, but you will be thrown off by the double velocity as that of the lorry. Clear?